Okay, in this lecture video, we're now going to talk about uncompetitive inhibition. So uncompetitive inhibitors and how do they function? So in the case of uncompetitive inhibition, we're talking about a molecule that binds to the enzyme substrate complex. So it cannot bind until substrate is bound to the enzyme. So it binds at some location other than the active site. So it can't bind, obviously it can't bind to the active site if the substrate is in there. So in terms of our schematic about how we talk about this, now we're talking about this case where you have a competition for inhibitor for the enzyme substrate complex, to where you form this ternary complex of enzyme, substrate, and inhibitor. So now in this case, we're talking about a new Ki. I'm going to pick Ki prime because we're talking about an Ki for a inhibitor that is not competitive. So now we're talking about, again, products over reactants. So for that dissociation constant, the products over the reactants would look like that. So now, when we look at how the kinetics are affected, you can do a bunch of math, which we're going to skip here. You get an effect on the initial velocity that looks like this. Since we're not binding directly to the active site, we're not going to have our alpha by our Km, but instead we're going to have it over here. And I'll have it be alpha prime again, since we're talking about a new type of inhibitor. But the definition is still the same. So what we're looking at here is an inhibition effect that's going to affect both substrate binding and catalysis. So if we were to do an experiment to try and figure out what that type of inhibitor looked like, and we made our double reciprocal plot, it would look like this. So now, again, we've got no inhibitor and then increasing concentration of inhibitors from experiment 1, experiment 2, experiment 3. So now what we see is that 1 over Vmax, which is this intercept here, so again, that's 1 over Vmax. 1 over Vmax is increasing as you add more inhibitor. That means we have a decrease overall in Vmax in the presence of an uncompetitive inhibitor. And what we also see is that the x-intercept, which we said was minus 1 over the Km, that minus 1 over the Km is also getting larger as you add more and more inhibitor, which means the Km is getting smaller. So in the presence of an uncompetitive inhibitor, we've got a decrease in the overall velocity and a decrease in the affinity of the enzyme, or excuse me, a decrease in the Km value for that enzyme. And mathematically, if you think about it, it makes sense. If you're decreasing the Vmax value, it's not surprising that it would take less substrate to reach that value. So the new K prime that we have, the new modified value of Km is the original enzyme's Km divided by alpha prime, where again, alpha prime depends on the concentration of inhibitor and the dissociation constant Ki for that particular inhibitor from the enzyme substrate complex. We can also say or show that how the initial velocity is going to change, or excuse me, how the maximum velocity is going to change, it also gets modified by that alpha prime term. Most importantly, what we can see, though, is that if we have this molecule, this new inhibitor that's been discovered, we can now, it should be clear that we could compare these double reciprocal plots And we see that we get different effects on Vmax and Km depending on how that inhibitor is functioning. Clearly, a competitive inhibitor yields a different plot as opposed to this uncompetitive inhibitor. And we'll see the same for the other two cases of inhibition as well.